Example number 65. Use integration to determine the length of the curve. Use integration to determine the length of the curve y is equals to 1 over 3 x raised to power 3 over 2. Between the points x is equals to 0 and x is equals to 4. So use integration to determine the length of the curve y is equals to a third x raised to power 3 over 2. Between the points x is equals to 0 and x is equals to 4, isn't it? So we said for you to get the length of a curve, you integrate from the given limits, isn't it? Then square root of 1 plus the derivative of that function, then you square that derivative with respect to x, isn't it? So our function here, of course, y is a function of x, meaning the function of x remains the function of x, isn't it?
Yes.
Are we together? For you to determine the length of a curve, you find the square root of 1 plus, you get the derivative of that function, then you square it, isn't it? So let us start. What is y? Y is a function of x. So if y is a function of x is equals to what? Y is equals to 1 over x raised to power. But we don't want function of x, we want its derivative, isn't it? Yes. Meaning if you differentiate a function of x, you get 3 over 2 times a third. So you have 1 over 2. 3 over 2 times a third, polynomial. You have a half x, then you reduce the power by 1, raised to power. Isn't it? See, that's how to differentiate a polynomial. So you get a half x raised to power half. So you found f prime of x. This times this, you get a half, isn't it? Yes. Then you reduce the power by 1, you remain with a half. But we want f prime of x squared, meaning we now, after differentiating, we square both sides after differentiating, isn't it? If you square both sides, what do you get? A half squared becomes 1 over. See, this square outside is for everything inside. See, a half squared becomes 1 over 4. Then this a half and this 2 times power half. So you remain with x. Isn't it? See, the power outside times the power inside, lots of indices. See, 2 times power half, so you just remain with x raised to power 1, which is just x, isn't it? Then after that, what do we want? We want 1 plus f prime of x squared, meaning 1 plus 1 over 4x. 1 plus this. This we found is a quarter x. So we have 1 plus 1 over 4x, isn't it? Are we together? So it means the whole of this problem is the same as from A to B is from 0 to 4. Then square root of 1 plus f of f prime of x squared you found is 1 plus a quarter x dx. Are we together? Now, having found that, we now integrate. So if you do integration here, you can see this is direct algebraic substitution, because when you take u to be what is inside the bracket, you will get the u to be the x, isn't it? Are you seeing that? So when you take u to be what is inside the root, meaning if you take u to be 1 plus a quarter x, if you differentiate u with respect to x, differentiating 1 you get 0, isn't it? Differentiating 1 over 4x, you get 1 over. So you take the x the other side, you get you get 4du is equals to the x, isn't it? Meaning if you multiply both sides by 4, you get 4du is equals to, isn't it? Cross multiplication. See, 4 times the u is 4du. Dx times 1 is in the dx. Meaning where there is dx, we are going to put 4d du. So it means this one is what? So it means when it is indefinite, when you are integrating square root of 1 plus a quarter x dx, this is the same as you are integrating 1 plus a quarter x is u, meaning square root of u. Dx is the same as 4du. You factorize out 4 outside, then you put the u there, isn't it? So it means this is 4 into integral of u raised to power half du. Are we together? Is that okay? So what do you get? 4 into, when you integrate u raised to power half, so you add 1 to the power. You get 3 over 2 divided by 3 over Isn't it?
Yes.
Then after doing that, you take back your u value. Is that okay?
Yes.
Are we together?
Yes.
So if you take back the u, I have 4 divided by 3 over 2, you get 8 over 3, isn't it? Are we together? 8 over 3 into u, but your u is 1 plus a quarter x, and that u is raised to power 3 over 2. Are we together? Isn't it? So it means your problem whereby you are integrating from 0 to 4 of square root of 1 plus a quarter x dx, you are supposed to get 8 over 3 into what? 1 plus a quarter x raised to power 3 over? 3 over 2. Then you now put your limits of integration from 0 to 4 because you transform everything back to x. Are we together? You put your limits of integration. So having done that, what do you get? Give me the answer. Go to the calculator. When you substitute when x is 4, look at it. It is very simple. When x is 4, see a quarter times 4 is 1. So it means what will be inside there is 2. Isn't it? So we have 8 over 3 outside, then upper limit is 2 raised to power 3 over 2, then minus the lower limit. When you substitute 0, you remain with 1, isn't it? 1 raised to power 3 over 2 is just 1. So if you evaluate that, what do you get? What do you get? 8 over 3 in bracket 2 raised to power 3 over 2 minus 1. If you substitute the limits, what do you have? Or the first one you have is 7.54. So this first part is 7.54. Then minus this second part is when you substitute 0. What do you get to be the answer? 1 plus?
I've done this for this, but I'm not doing for it.
Yeah, that is what I'm waiting for. So you've done for the upper limit, isn't it? You've done for 4 and you found 0.7. Then we are now doing for 0, isn't it? 0 is equals to, so for 0 you have 8 over 3, what I've written there, which is 2.67. So here we have 2.67. So what do you get to be the answer? 7.54 minus 2.67. What do you get to be the answer? 4.88. So you have 4.88. That is the length of that curve. Are we together? That is the length of that concept is very, very common in your area.